we've been working on this multi-span beam that has both chord movement and has loads in the two outer spans, three-span beam. And in the previous step, we wrote out all the K values, we wrote out all the fixed end moments, we handled the chord rotation terms, got that in terms of numbers, but we didn't really finish off step 2, which was to actually write in all the terms in for the slope-deflection equation for each member N. So we need to do that, and the thing about that is this gets long and tedious, and you're going to ask the question, do I really need to write all this out? The answer is yes. Right, so I write out everything symbolically in each and every member N moment, and then I come back and I start crossing out things that I already know are zero, such as theta A terms are 0. That was at that fixed N. That means at the other end of the beam, theta D's are 0. There was no chord rotation in that outer span, so those are zeros, and there's no applied loads in the middle span, so those are zeros of the fixed end moment terms. And then you get kind of a little excited and you start trying to cross out things that are not actually zero. Right, so be a little careful as you go through all this, and that's why I say it's important to write all of these pieces out, because it's very easy to make a mistake, and to do this, you know, really in steps along the way. So let me zoom in a little bit more here and hit the autofocus lock again. Try to hit the autofocus lock. There we go. Alright, so we want to substitute in for all these pieces, and certainly you can speed this up sometimes, but be careful. We've got 2e, and then the k of that member is 3k. That's why you got to be really careful, because this is going to change as we go along. And then we have 6ek AB times the psi AB term. That was a positive 72, and then that becomes a negative 72 there. And the fixed end moment AB, which was minus 166.7. Right? Simplifying that down, then we end up with 6ek theta B, and then minus 238.7. That's the equation for the moment AB. And you might recall we kind of guessed that the moment at AB would turn out to be around that order of 200 to 250 kilonewton meters, and that looks like it'd be a really good number if it weren't for that theta B will be some non-zero value. We're guessing that theta B will turn out to be a negative value, which means all of this will turn out to be even a little bit bigger than what we've got suggested here. Right, do the same thing for MBA. Notice the 2's and the 4's flip-flop, theta A term, and I encourage you again to keep writing these in these orders. Then this pattern of things is really pretty easy to work with. And so once again we'll have then 4e times 3k times theta B. We'll have a minus 72 and then a plus 166.7, and that will work out to then be 12ek theta B, and then the net we get here is a 94.7. Yes, you should have a 2-to-1 ratio on these rotation terms that are of the same location, the B in this location. Right, then you go to MBC, and there again, same old story here. 4e times, now for BC that's 4k theta B, plus then 2e times 4k theta B. The chord rotation term is different, and it is a negative value. It's a negative 64. So negative times a negative, we get plus 64, but we do not have a fixed end moment term. So that becomes a 16 ek theta B and a plus 8 ek theta C. And yes, you should have that 2-to-1 ratio there, and then plus the effective fixed end moment that comes from the chord rotation, known chord rotation value. Come along now to the second one, 2e times 4k times theta B plus 4e times 4k times theta B, and then plus 64, and that's going to shoot us over to 8 ek theta B plus 16 ek theta c plus the 64. Right, so yeah, you should have this flip-flop going on those coefficients, and because the chord rotation is what's causing this 64, then that should be exactly the same. If that had come from the loading term, then I'd expect the signs on those to flip-flop, as well as possibly magnitudes to change depending if it was a symmetric or asymmetric load on the member. And then the last member to work through, we've got the MCD, so that's in MDC, so let's see here, we got 4e times 3k theta c plus 2e times 3k theta d. Oh, oops, that's 0. We didn't really need to do that one. So 0 and 0, we don't have a chord rotation term, minus 208.3, and so that becomes 12ek theta c minus 208.3. I keep wanting to put a theta d term in there, but you could, it's just that it's going to be 0. Now, when you get pretty good at these, you can start to just write these down pretty quickly, right? We got these two 0 terms here, the fixed end moment terms flips-flops. That's what I was referring to before in that discussion up here. They're coming from a load, all right, that you can actually see down in here. And then we got that should be half, right? So 2e times 3k is going to be a 6ek theta c term right there. Right, and that's all of the last part of the step 2 to write all the member end slope deflection equations. Let me broaden that out for you so you see them all at once, and we'll get ready to go on to the next step.